Hey class, it's me, Mr. Stark. We're here today. This is gonna be Tuesday, I believe. Yesterday I spent some time talking about how the jumping paper, floating paper clip, and the scared pepper lab worked. Today I have a similar lab with called the soap motor boat lab. And basically what it does is kind of puts things together, and I'm going to have you do what's called a Flipgrid, a little video, 45-second video about how the soap motor boat works in terms of surface tension and cohesion. That information is is in here on the soap motor boat sheet. Okay, so I'm going to leave it at that. What you're going to need to do this is you're going to need a small piece of aluminum foil, and then this is maybe 5 by 8 centimeters, as it says on the lab sheet here. It can be a little bit bigger, it can be a little bit smaller, depending on the size of your if you're going to use the sink, whether you're going to use a bathtub or something like that to hold some water. And so first of all, what you're going to do is you're going to make a little boat that you're going to put on the water. So I'm going to flip my screen here and turn it down like such so that you can see what I'm doing here. I'm going to take the side, I'm going to fold it in like this. Take this side and fold it in like that. And then bring the front up and then bring the sides up. And just kind of crunch it all together like this so that we make a little boat, and then maybe fold the front inside kind of like that, and we have a little tiny U-boat. The back can stay open. The back can stay open. Okay. We're going to pause. Hey, we moved over here in the back of the room here. I'm going over to the sink to grab some water. And what I've got I've got a tray right here, that like a lunchroom tray, that'll work. You could do this in your sink. You could do it in your bathtub at home. Maybe you have a little Rubbermaid that you could use at home. Okay, anything that'll hold some water so you can get a little depth in your water. Okay, and I've just got, maybe I'm going to put a little bit more in there. Maybe I've got like a 1/4 inch of water in here. Okay, and now I'm going to sit down, and I got some Dawn dish soap here. You don't need a lot, you just need a drop. Okay, and so I took my little boat that I made, and I'm going to put that on the surface of the water, and you can kind of see that it'll float. And if I move my hand around, and you can kind of blow it around so it'll float. Okay, and air currents will make that thing move around a little bit. And so the objective is, and why is it floating on the surface of the water? There is a force, an attraction force between the water molecules that creates a surface tension, kind of a little elastic skim on the surface, and that is created by cohesion, the attraction of one molecule of water to another molecule of water. Again, we can get this to slide across the surface, okay, by just blowing and moving some air around. Okay, so now what I'm going to do is going to dry that off a little bit, and I am going to take 1 drop of soap and put it on the back of the boat. 1 tiny drop of soap on the back of the boat. And then I'm going to set the boat in the water. and you can see that the boat was skimming across the water. Okay, the soap did something to the surface tension of the water and caused the boat to skim across the surface of the water and be propelled forward. Okay, I'd like you to try this at home. Your job will be to make a flip grid, and I'll have this set up for you, explaining what happens to the surface tension, why the boat floats, why the surface tension keeps it up, and what happens when the soap gets in between the water molecules. Okay, how does the soap affect the surface tension and the cohesion of the water? That's a big hint for you for your answer for your flip grid. Thanks. Have fun. Have a good day.